Biological rhythms. So this video is going to look at circadian rhythms and then infradian and ultradian rhythms. So the chances are circadian could be asked as a 16 marker in itself. Likelihood that infradian and ultradian would be a 16 marker together. So it's going to be looking at all three in one biological rhythms video. So circadian rhythms are biological rhythms that last approximately in around 24 hours. So they adapt the body to meet the demands of the day and night cycle. Now it's believed to be controlled by the suprachiasmatic nucleus in the hypothalamus. Now light levels cause neural signals to be sent to the suprachiasmatic nucleus, and that allows the circadian rhythm to be synchronized with the daylight hours. So photoentrainment. Our body generally follows a 24-hour pattern. So for example, our strongest sleep drive is usually between 2 and 4 AM and then again at 1 and 3 PM. Obviously, sleepiness is more intense if we are sleep deprived. Now, this free-running internal circadian clock maintains a cycle of 24 to 25 hours, even in the absence of external cues. But they can be disrupted by major changes in sleep schedules, jet travel, so jet lag, and shift work. But generally, our body's clock is 24 hours. Other examples of circadian rhythms are our core's body temperature. So it tends to be lowest, so about 26 degrees Celsius at 4:30 AM and highest about 38 degrees Celsius at around 6 PM. So it dips between 2 and 4 PM as well. Also, hormone production follows the circadian rhythm. So melatonin is produced by the pineal gland and it peaks during the hours of darkness, which promotes sleepiness. So that we talk about melatonin in the endogenous pacemakers video. So for example, outline one example of a circadian rhythm, total of 4 marks. So you could talk about the sleep-wake cycle, which is probably the most people would naturally talk about. So the sleep-wake cycle is 24 hours long, and that is controlled by the suprachiasmatic nucleus, which is located in the hypothalamus. It receives environmental light signals that it causes it to synchronize with the day and night cycle, which keeps people in a 24-hour cycle. So you make sure you have 4 sort of key points of that circadian rhythm. So we've got supporting evidence. So from Michael Schiffer. So he spent 6 months in a cave in Texas with no daylight, clocks or radio, and yet his circadian rhythm still was 24 hours. So that is a good indicator that our circadian rhythms, even without external cues, is 24 hours. So our sleep-wake cycle is 24 hours long. However, we've got contradictory evidence from individual differences. So some people call themselves a morning person, some people call themselves an evening person. And also the cycle can vary between 13 hours up to 65 hours. So it all depends from person to person. So we can't make this general law that our biological clock is 24 hours. Others suggest that temperature is more important than light in helping set and regulate our body clock. So it seems that the suprachiasmatic nucleus transforms information about light levels into neural messages that sets the body temperatures. But researchers found that fluctuations in body temperature cause tissues to become more active or inactive. So actually temperature is more important than those light as an external cue. There we've got usefulness, so real world applications. So it's found that timings of the day can affect drug treatments. So to be most effective, drugs might need to be released into the body at a certain time. So the risk of having a heart attack is greater in early morning. So therefore this promoted the development of a drug delivery system. So the drug is released into the bloodstream during that early morning period. Now, it's quite difficult to test, and much of the research has been criticised for its lack of external validity. So for example, It's been carried out in artificial conditions, so it has low ecological validity and therefore resulting in behaviour that could be similarly false. So we should be cautious when applying those findings from an artificial lab experiment into an everyday setting. So are the findings and the conclusions, are they as accurate as what we first think? So in terms of 16 marker, as I said, it's likely that you'd get a 16 marker just on circadian rhythms. So discuss research into circadian rhythms. Remember, research is theories, explanations and research studies. So not purely just wanting you to talk about a research study. You can talk about the explanation and theory behind circadian rhythms. Discuss, once again, means outline and evaluate, so please make sure you are doing your evaluation in there and not purely just outlining circadian rhythms. So moving on to infradian rhythms, so they are rhythms that last more than 24 hours. So for example, the menstrual cycle. So that's dictated by our endocrine system. However, it's not solely down to the release of hormones. It's been found that zeitgebers, so exogenous zeitgebers, have an effect. So external cues might have an effect, such as light and odours. So McClintock and Stern found that women who received odorless, so they got women to receive odorless compounds from the armpits of women at different stages in their menstrual cycle. Now, if that compound had came from a female in the latter half of her menstrual cycle, the receiver of those compounds, their menstrual cycle was also shortened due to the other woman's pheromones. If the compounds have been collected by a woman at the beginning of her cycle, that caused the other woman's menstrual cycle to lengthen. So this indicates that there are external factors that can influence the infradian rhythms. So an example of a question, the human female menstrual cycle is an example of one type of biological rhythm. It is called A, circadian rhythm, B, infradian rhythm, or C, ultradian rhythm. So you should identify that that is B, infradian rhythm. So in terms of evaluation, so it might be evolutionarily advantageous for women to have menstrual synchrony, for women's menstrual cycles become in sync with one another. So if women menstruate at a similar time, that means that they are fertile at a similar time and therefore they might fall pregnant at the same time. This would mean that any newborns could be cared for collectively and therefore increasing the chances of survival for the offspring and therefore increasing chances of later reproductive success. So therefore it might be evolutionary value, we might have adapted to have this menstrual synchrony. A weakness is there is methodological problems with synchronization studies. So there's many factors that can affect a women's menstrual cycle rather than just odours. So there could be a number of confounding variables such as stress levels, changing in exercise and diet. So that weakens the support that odours are an important exogenous zeitgeber influencing a female's menstrual cycle. In terms of ultradian rhythms, so they are biological rhythms that last less than 24 hours. So it's likely that you would go through numerous of these cycles within a 24-hour period. So for example, the sleep cycle has 5 stages and it occurs through a night, and the length of each cycle is about 90 minutes. So you will go through a number of these sleep stages. So stages 1 and 2 is light sleep and you have alpha and beta waves. Stages 3 and 4 are deep sleep with delta waves, and then stage 5 is where you have rapid eye movement, so dreaming occurs and the brain is active. Now, as I said, a cycle of the sleep cycle is about 90 minutes and it's likely that you would probably go through 4 to 5 of these sleep cycles in a night time. Another example is Brax. So the 90-minute cycle is of the basic rest activity cycle, and that is during the day. So sleep cycle at night time, the basic rest activity cycle during the day. So it's the idea behind it is that during the day we move from a state of alertness to a state of physiological fatigue. So again, approximately every 90 minutes. So research suggests that the human mind can only focus for a period of about 90 minutes, and at the end of that 90 minutes the body begins to run out of resources. So this is an ultradian rhythm. We go through a number of these cycles throughout a 24-hour period. So we have some supporting evidence that found that elite violinists will practice for about 90 minutes at a time, and they'll often take a nap and after that 90-minute cycle. So it supports the existence of that practice cycle, that ultradian rhythm of alertness and then fatigue. However, again, individual differences in sleep patterns may be biologically determined. So it's found that large differences between individual sleep patterns, which were consistent over 11 nights in a controlled sleep lab, individuals also responded very differently to a 36-hour period of sleep deprivation. So it might be that that sleep cycle isn't the same for everyone, so we should be careful about creating general laws and taking a non-methodic approach. Outline and evaluate research into infradian and ultradian rhythms. So I would structure this in terms of talking about infradian rhythms, so my AO1 paragraphs on what they are and the female menstrual cycle, then evaluation of the benefits of having menstrual synchrony and then the problems with the way the research was conducted. Then I'd move on to ultradian rhythms, so the idea that these are shorter than a 24-hour period and we go through numerous cycles within a 24-hour period. So the sleep cycle and the Brax cycle, talk about those, and then evaluation points, so strengths and weaknesses of that. So the supporting evidence from elite violinists, and then the weakness of individual differences and sleep patterns.